Hello students, today we are going to study about vectors. Already you are familiar with the concept of vectors. What are vectors? Tell me. Yes, any physical quantity having a magnitude as well as a direction. It's called as a vector. So to express a vector completely or fully, we need two things. What are the two things? One is the magnitude of the vector. Magnitude means the length of the vector, and direction. Now, how do you represent a vector in a plane? A vector will be represented by using a directed line segment. What is a directed line segment? A directed line segment has a magnitude as well as a direction. The direction will be shown by an arrowhead. So the directed line segment will point in the direction in which the vector is acting. Now, in this case, O will be called as the initial point of the vector and A will be called as the terminal point of the vector. So, let us see some of the important concepts here. One is equality of vectors. Now, when do you say that two vectors are equal? Let us consider two vectors like this. Now say these two vectors have same magnitude as well as same direction. Then they are said to be equal. Now since the vector has magnitude as well as direction, only by having the same magnitude vectors will not be equal. So two things should be there. Their magnitude should be same. Magnitude same as well as direction should be same. So if the magnitude of the two vectors is the same as well as the direction is same, then we'll say that the two vectors are equal vectors. Now consider a case like this in which the two vectors are in the same direction but their magnitude is not the same. Two vectors are in the same direction but their magnitude is not the same. So say this is vector A bar here, this is vector B bar here. Then in this case, I can express vector B bar at some multiple of A bar. This is called as a scalar multiple. So take for example, if I can express vector B bar at say 5 times vector A bar, then that will mean vector A bar and B bar are in the same direction and the magnitude of vector B bar is 5 times magnitude of vector A bar. Now, how will you add two vectors? Obviously, because vectors have magnitude as well as direction, I can't just add them algebraically. So here we are going to use something called as triangle law of vector addition. So suppose these are two vectors. I am completing this triangle. So how I drawn these vectors? Suppose OA is vector A bar and AB is vector B bar. Now vector B bar I have drawn in such a way that its initial point coincides with the terminal point of the first vector. Then the third side here the vector along the third side will represent the sum of the two vectors. So the sum or the resultant of the two vectors will start from the initial point of the first vector and it will end at the terminal point of the second vector. Okay, now let us come to some important type of vectors. One of them is the unit vector. Now what is a unit vector? Unit means 1. So any vector whose magnitude is 1, any vector whose magnitude is 1 is called as a unit vector. Now, there are two very important unit vectors for solving the problems, and those are I vectors and j vectors. So let us study them. So suppose this is the xy system here. This is x-axis and this is y-axis. So a unit vector that is in the positive x direction, a unit vector that is in the positive x direction will be taken as the I vector. So starting from the origin along the positive x direction, this will be the I vector. And a unit vector that is in the positive y direction will be the j vector. So these two vectors are very important as far as solving problems are concerned. So let us see some of the problems here. Now let us first see how to express a vector in terms of I and j vectors. So let me draw the xy system here. So in this xy system, say there is a vector here that is in the first quadrant. This is point A. Now suppose the coordinates of A are 3 and 4. So I will draw a perpendicular on x-axis here. Suppose this is M, this is O, and since I is the unit vector in positive x direction, the magnitude of OM is 3. So vector OM, I can take it as 3i. And similarly, now MA is parallel to positive y direction and the magnitude of MA is 4. So vector MA can be taken as 4j. So if I use the triangle law of vector addition, I can say OA is equal to OM plus MA. Now here OM is 3i and MA is 4j. Now for solving the problems, I will express this vector as a column vector. If I express a vector which is in ij form as a column vector, solving problem becomes easier. Secondly, I want to find out the magnitude of vector A. Any vector will be expressed in terms of its magnitude and direction. Direction will be given by the angle. Angle can be expressed in different ways, either made with the positive x direction or positive y direction or even as a bearing. Now, to find out the magnitude of vector OA, I will use the Pythagoras theorem. So, since this is 90 degrees, the length of OA, that is the hypotenuse, will be OM square plus MA square. Now OM, the length of OM is 3. So 3 square plus 4 square, square root of this. This is simple Pythagoras theorem, which is 9 plus 16, 25. So the magnitude of vector OA is 5. Keep it in mind that I will not take the negative square root because the magnitude cannot be negative. Now I will take this angle theta here. So tan theta, using SOHCAHTOA, tan theta is opposite side upon adjacent side, that is 4 upon 3. So theta will be tan inverse of 4 upon 3. So how much is tan inverse of 4 upon 3 in degrees? It will be about 53 degrees. To nearest degrees, I can say that this is 53 degrees. Now suppose I want to express the direction in terms of bearing. Now what is the bearing? It is the angle made with the north direction in the clockwise sense. Okay, so obviously in this case the bearing of this vector will be 90 minus 53, because the bearing will be in this case this angle starting from north up till line OA. So that will be 90 minus 53, so which is 37 degrees. So this vector is on a bearing of 37 degrees. Let us take one more problem on this. So let us consider one more vector. Now suppose in this case the vector is in the second quadrant. This vector is say OA here, that is A bar, and say A bar is in terms of I and J vectors, it is minus 5i plus 3j. Okay, so I am drawing this perpendicular here. AM perpendicular on x-axis. So this angle is theta. So in this case, the magnitude of vector A will be root of, now in this case, length of OM is 5 and AM will be 3. So the magnitude of this vector will be root of 5 square plus 3 square, which is 25 plus 9, which is root 34. That is the magnitude. Now, Suppose I want to express the angle as the angle made by the vector with positive x direction. Angle made with the positive x direction. So, first let me find out this theta. Theta will be tan inverse of 3 upon 5. Tan inverse of 3 upon 5, which is 30, about 31 degrees. So the angle made with the positive x direction will be this angle here, which will be obviously 180 minus 31. So angle made by the vector with positive x direction will be 149 degrees. Now suppose I want to express the direction of this vector in terms of the bearing. Now as you have just now seen, bearing is nothing but angle made by the vector from the north direction in the clockwise sense. So that will be this full angle, which will be 270 plus your angle theta here, which is 31. So 270 plus 31, which is 301 degrees. So the bearing of this vector will be 301 degrees. This is how you can express the direction of a vector in different ways. Now let us see some of the problems here. Say vector A bar is 3i plus 4j and vector B bar is 4i minus 3j. So you have to find the vector A bar plus B bar, and secondly 3a bar plus 2b bar. Now as I told you just now, in such cases express the vector as a column vector. So A bar I will express it as vector 3, 4. B bar is 4 minus 3. Now first I want vector A bar plus B bar, which is 3, 4 plus 4 minus 3. So that is 7, 1. So now express this in terms of I and j. So it will be 7i plus j. Similarly, 3a bar plus 2b bar, which is 3a bar, 3, 4, and 2b bar, that is 2 into 4 minus 3, that is 9, 12 plus 8 minus 6. So whenever you take this scalar multiple, multiply both the component by the scalar outside. So that will become 9 plus 8, that is 17, and 12 minus 6, that is 6. Add component wise, x with x, y with y. So finally it is 17i plus 6j. So vector 3a plus 2b is 17i plus 6j. Now take a problem like this. Vector a bar is 4i plus 5j and vector b bar is 9i minus 3j. Now suppose vector a bar plus lambda times b bar is parallel to vector I bar. Find the value of lambda. Now, since the vector is parallel to I, that means a vector parallel to I will be a scalar multiple of I. That means it should be in some ki form, or which I can write it as ki plus 0j, which will mean the coefficient of j should be 0. So first, find out a bar plus lambda times b bar. Now here, a bar is 4, 5 and b bar is 9 minus 3. So first find a bar plus lambda times b bar, that is 4, 5 plus lambda times 9 minus 3. So it is 4 plus 9 lambda and 5 minus 3 lambda. Now since the vector is parallel to I, the j coefficient equated to 0. That means 5 minus 3 lambda equates to 0. And so lambda will be 5 upon 3. Now in a similar way, if the problem says the vector is parallel to j vector, equate the I coefficient to 0.